find the equation of a quadratic if you are given the roots. What you want to use is the sum and the product formulas that was mentioned in the video right before this, that the sum of the roots you get from the formula negative b over a, and the product of the roots is from c over a. So if I find the sum and the product, I could find a, b, and c and write my quadratic from there. So the sum of the roots, if our roots are 4 and negative 2, what do they add to? They add to positive 2. The product of the roots, 4 times negative 2, is negative 8. Now I want these to be fractions, and I need to be fractions with a common denominator. And since they're both whole numbers, I'm just going to put them over 1. So the sum is equal to negative b over a, and the product is equal to c over a. So clearly, I see that a equals 1. And b, well, if negative b is 2, then b is negative 2, and c is negative 8. That means my quadratic is y equals 1x squared, because it's ax squared, minus 2x for bx, minus 8 for c. A little bit more complicated when your roots are complex, like 2 plus 3i and 2 minus 3i. But the sum is actually very simple because the plus 3i minus 3i cancel each other out. The sum is just 4 over 1 here. The product, on the other hand, I do need to do a little bit of work. I need to multiply 2 plus 3i times 2 minus 3i. Now you might recognize that these are conjugates. So I could do the whole FOIL process, or because they're just conjugates, I can multiply the first and the last because I know my middle terms are both positive 6i, negative 6i. They'll cancel each other out. So first it multiplies to 4. 2 times 2 is 4. Positive 3i, negative 3 is negative 9i squared, but I know that I squared is negative 1, so we turn to 4 plus 9, and the answer is 13, and I put it over 1 to make it a fraction. So again, the sum is negative b over a, and the product is c over a. So a is 1, b is going to be negative 4, because we know that negative b is 4, and c is 13. So that's going to be y equals 1x squared minus 4x plus 13. And it's the same for if our roots were radicals as opposed to imaginary.